By the end of this unit, you will outline the main pathological mechanisms exerted by air pollutants leading to disease. The main ways in which pollution can affect organs, causing systemic inflammation, are trigger of oxidative stress, regulation of the immune system, pro-inflammation pathways, and epigenetic regulation. Air pollution is a trigger of oxidative stress via pro-inflammatory cytokines, which are small proteins released by cells in the immune system. Cytokines, such as tumor necrosis factor alpha, are involved in the systemic inflammatory response induced by exposure to particulate matter. In addition, proteins such as toll-like receptor 4 lead to the production of pro-inflammatory cytokines. Once inhaled, PM2.5 penetrates deep into the pulmonary tract, reaching alveoli. PM2.5 is able to interact with and activate local cells such as resident macrophages, dendritic cells, and alveolar or endothelial cells, while modifying endogenous structures such as cell membranes, surfactant lipids, and antioxidants. An inflammatory response can be instigated by mediators of oxidative stress such as free radicals in response to the activation by PM2.5. These are directly generated by particulate compounds or produced in response to biological intermediates such as modified phospholipids. As a reminder, ultrafine particles and other pollutants are able to pass the alveolar capillary membrane, then be endocytosed or internalized into immune systems-related cells and distributed throughout the body via the bloodstream. They are therefore able to induce similar and systemic inflammatory reactions in other organs. As regards the epigenetic regulation, there is evidence that air pollution induces epigenetic changes like DNA methylation and others associated with a pro-inflammatory response. You have now completed Unit 3. Please download the reading material for further information. In the next unit, we will look at the short-term and long-term health effects of air pollution.
Welcome to Unit 4. Short-term and long-term health effects. By the end of this unit, you will outline the short-term and long-term health effects of air pollution. Let's start by defining what we mean by short-term and long-term exposure to air pollutants. Short-term exposure means hours, days, and weeks. Long-term exposure is months and years. Short-term exposure to air pollutants has been associated with chronic obstructive pulmonary disease, or COPD, respiratory illnesses, higher rates of hospital admissions or medical visits, and all-cause and specific cause mortality. Long-term exposure to particulate matter has been associated with the onset of cardiovascular and cardiopulmonary mortality, lung and heart disease, lung cancer, as well as poor mental health. These causes of death and disease have been associated with other pollutants such as nitrogen dioxide, carbon monoxide, and ozone. Exposure to PM2.5, nitrogen dioxide, and carbon monoxide during pregnancy has been associated with adverse pregnancy outcomes, with health consequences for individuals throughout their life cycle. The burden of morbidity and mortality from air pollution, estimated in epidemiological studies, is higher at the population level for long-term exposure than for short-term exposure. This demonstrates that long-term effects are not merely the sum of short-term effects. While in the past, researchers were focusing their attention on the short-term effects of air pollution, this changed considerably when it became clear that long-term exposure to particulate matter has a much greater effect on human health than short-term exposure. You can download the reading materials to get more detail on the associated long-term and short-term health effects of particulate matter, nitrogen dioxide, ozone, and carbon monoxide. You have now completed Unit 4. In the next unit, we will look at the populations at higher risk.
populations at higher risk. By the end of this unit, you will recognize which populations are at higher risk from the adverse effects of air pollution. To understand who is at higher risk from the adverse effects of air pollution, it is important to clarify the concepts of susceptibility and vulnerability. Susceptibility is an innate or acquired physical predisposition that increases the relative risk of experiencing health effects as a result of air pollution exposure, such as pre-existing conditions or diseases. Susceptibility includes life course factors, for example, being an older person, a child, or a pregnant woman. Genetic factors including certain polymorphisms as well as genetic disorders, and pre-existing conditions or comorbidities such as chronic diseases, respiratory diseases, or other non-communicable diseases like diabetes. Vulnerability means that people have increased exposure to air pollution due to external factors, such as place of residence, work, or home, especially if close to traffic or closer to other sources of emissions. Precarious living conditions, for example, living in slums, the type of occupation, for example, street vendors or other forms of outdoor workers, as well as low socioeconomic status. Factors associated with lower socioeconomic status that can make a person more vulnerable to air pollution exposure includes poor diet, lack of exercise, lack of access to green spaces, lack of access to healthcare, living next to a busy road, having to commute in busy traffic, and lack of access to clean energy at a household level. Susceptible population groups differ between short-term or long-term exposures. Even apparently healthy people are susceptible to the effects of long-term exposure to particulate matter. Exposure can potentially accelerate progression of disease or even initiate it until it is clinically diagnosed. However, the most susceptible to the effects of short-term exposures are those with an unstable and/or chronic conditions or comorbidities. As noted, different life course factors can bring increased susceptibility to air pollution, in particular for older people, children, and pregnant women. The number of people aged over 60 is expected to double by 2050, a new demographic reality that must be taken into account when we consider diseases related to air pollution at the population level. The reason for the increased susceptibility of older people is that, at a biological level, the aging process is associated with a gradual accumulation of molecular and cellular damage. Over time, this damage leads to a gradual decrease in physiological reserves, with increased risk of many diseases and general decline, which make older people more fragile. Increased exposure to pollution has been associated with increased mortality, hospital admissions, and emergency room visits for older people, mainly the result of exacerbation of chronic diseases or respiratory tract infections. As we said, comorbidities can affect susceptibility, and older people are the population group most likely to suffer from such conditions. Children are also at greater risk than adults from the many adverse health effects of air pollution because of a combination of physiological, environmental, and behavioral factors. Children's immune, respiratory, and central nervous system are still developing, and so they are highly sensitive to environmental stimuli, including air pollution. They are especially susceptible during fetal development and in their earliest years, while their lungs, organs, and brain are still maturing. Children breathe at higher rates to adults and more frequently breathe through their mouth, so that they take in air pollutants at higher doses. Their lower height also means that they live and play closer to the ground, where some pollutants reach peak concentrations. They also tend to engage in more outdoor physical activity. Children are exposed starting from the womb, as they are vulnerable to their mother's exposure to pollutants. Particularly in low and middle-income countries, young children spending time with their mothers in the home are exposed to household air pollution from the use of unclean fuels and technologies for cooking, heating, and lighting. Download the reading materials for more details on air pollution risks to children. Women are considered a population at higher risk of experiencing the negative health effects of air pollution, particularly in the context of household air pollution. The reason for these gender inequities is that in low and middle-income countries, women are generally more exposed to air pollution deriving from the use of unclean fuels and technologies for cooking, heating, and lighting in and around the home. Together with children, and especially girls, they are the main procurers of fuels, which is linked to both health and safety risks, as we learned in Module 2. You have now completed Unit 5. Please download the reading material for further information. Now try the end of module quiz.